My name is Abhishek Thakur. Today I am presenting my topic sensor technology. Now, firstly, we have to know that what is a sensor. A sensor is a device that receives and responds to a signal. A sensor sensitivity indicates how much the sensor output changes when the measured quantity changes. Sensors are a new solution of measuring currents and voltage in medium voltage power systems. A typical example is a mercury used in glass thermometer that measures the temperature. Now, we have to know that the uses of the sensor is that the sensor are used in everyday objects such as touch sensitivity elevator, buttons and lamps which dim or brighten by touching the base. Now, the second use of the sensor technology is there are innumerable application of this technology which most of the people are not aware. The most important application included in cars, machines, aeroplanes, medicine, manufacturing and robotics and many more. Infrared sensor there are used in houses and in hotels at automatic lights and water taps. These infrared rays are used in tap also. Photoelectric sensor. A photoelectric sensor or a photo eye is used to detect the distance, absence or presence of an object by using a light transmitter and a photoelectric receiver. They are used extensively in industrial manufacturing. They are used in street lights. The street light automatically turns on and off as the sun rises and sunset. This is implemented by using photoelectric effect. The street lights automatically turns on and turn off on the basis of darkness measured by the sensor. Automatic stairs. It starts running and stops automatic as it senses the presence or absence of a person, as we seen in the hotels or malls, etc. Now the sensor nature. It is sensitive to measure property. It is sensitive to any other property. It does not influence the measured property. A bad sensor has the following characteristics. If a sensor is not ideal, several types of deviation can be observed. The sensitivity may differ from the value specified. This is also called sensitivity error. And some other attributes of a sensor are: the output signal of a good sensor is linearly proportional to the value of the measured property. The sensitivity is then defined as the ratio between output signal and measured property. Sensor is linear because the ratio is constant to all points of measurement. Resolution. The resolution of a sensor is the smallest change that it can detect in the quantity that is measuring. In a digital display, the least significant digit will fluctuate indicating the changes of its magnitude. The example of the resolution of the sensor is that a scanning tunneling probe resolves into atoms and molecules. Now let me explain the types of a sensor. There are 4 types of sensor: optically, microwave, biosensor, non-biological sensor. Firstly, we have to discuss the optically sensor. The sensor observes visible lights and infrared rays. There are 2 kinds of observation method using optical sensor. Firstly is visible near infrared sensing. Secondly, thermally infrared remote sensing. Microwave sensor. These sensors receive microwave using its longer wavelength than visible light and infrared rays, and observation is not affected by day, night or weather. There are 2 types of observation that are occurring during the microwave sensor: active type and passive type. Now, third one is the biosensor. In biomedicine and biotechnology, as we see that the sensor which can detect analysis thanks to a biological component such as cells, proteins, nucleic acid and biometric polymers are called a biosensors. And the lastly is the non-biological sensor. A non-biological sensor for both sensor, even organic carbon chemistry for biological analysis, is referred to as a sensor or a nanosensor. This terminology applies for both in vitro and in vivo applications. The biological component in sensor present within a slightly different problem than ordinary sensor. Now, the properties of the sensor technology is that the natural properties of the soft iron core as a maximal flux density on and lack of linearity in the extension curve has sets limits for the possibility to reduce the transformer size and to use the transformer in a wider range of application. These principles are far from new. They are generally as old as the principles of conventional inductive instrument transformer. Thank you.